Sphaerotholus is an already named genus of Pachycephalosaur. The Pachycephalosaurs being the herbivorous dinosaurs with the domed heads that would, run into one another, or at least fight in that kind of combat within their own species. However, there's been a few of these species named within just the genus Sphaerotholus. There's Sphaerotholus goodwini from the Kirtland Formation of New Mexico that lived during the late Campanian stage of the Cretaceous, as well as Sphaerotholus buchholzei, which lived in the very end latest Maastrichtian and was from the Hell Creek Formation. There's also Sphaerotholus edmontonensis, which was described years ago and not recognized as a pachycephalosaur until much more recently, and that would have lived right about the boundary of the Maastrichtian, the last stage of the Cretaceous, and the preceding Campanian, right around that boundary. And now there's two more species to add to this fairly diverse genus. There's Sphaerotholus lionsii, coming from the Dinosaur Park Formation that would have been during the Campanian, and there's also Sphaerotholus triregnum from the Hell Creek Formation, the same formation as Sphaerotholus buchholzei. This means that there were at least 5 different species of Sphaerotholus around during the last 10 million years or so, in which the dinosaurs actually lived before the giant rock hit from space. It also provides good evidence for anagenesis, which is this idea of one organism evolving directly into another. Now, because of how biology works, we know that must be the case. That must be how evolution happens. New species don't just show up out of nowhere. However, it's very rare that we actually find good evidence for it in the fossil record. For example, Sphaerotholus lionsii had 2 rows of these kind of ornamentational knobs on the back of its skull. The later Sphaerotholus triregnum actually had 3 of these. Meanwhile, Sphaerotholus goodwini and buchholzei had 1 of these rows, and again, that is still tracking throughout time, at least with those animals. This suggests that early on in the genus Sphaerotholus, there was a split, with some of the organisms having just 1 row of these ornamental knobs on the back of the squamosal bone, and some of them having multiple rows of these knobs on the back of the squamosal bone. Unfortunately, Sphaerotholus edmontonensis is a little hard to know because we just don't have that particular bone that would preserve that trait. However, based on some other traits, it is thought of as being pretty closely related to Sphaerotholus buchholzei. Having this much diversity, though, makes sense when you look at a lot of modern-day ecosystems. For example, if you just think of the Rocky Mountains in general, you have a lot of different herbivores. You have moose and elk and multiple species of deer and pronghorn and bison when you get out into some of the more prairie-type environments. There's a lot of herbivores, and as you continue to go down into smaller and smaller herbivores, you get more diversity with many different kinds of small rodents and squirrels and rabbits all living in the same place. So, hypothetically, in the fossil record, there should be a broader diversity of smaller organisms, and we just don't find them. But that's the nice thing about this paper. We are starting to find some of these and show that, these ecosystems are pretty similar to what we would expect in the modern day, with some species being very closely related, but still occupying different niches as they evolved alongside one another. It also helps to really highlight that paleontology still has new things to find. These are from the Dinosaur Park Formation and the Hell Creek Formation. These are really, really well-studied sediments. We know of a lot of fossils from there, and there's still new dinosaurs to be found in them, meaning that there's probably still a lot of new dinosaurs to be found elsewhere as well.